I was a Google Summer of Code student this year for the Blender Foundation, and my project was to improve the workflow regarding motion capture data, allowing users and artists to retarget the animation, edit the animation before and after retargeting, and generally improving the way Blender handles motion capture data. In this video, I'll showcase all the new functionality, show you how to use it, and give you ideas of what the add-on can do. So as I mentioned, the work was bundled in a single Python add-on. So the first step that we're going to do is activate that add-on. So we just go to User Preferences, and under Add-ons, Animation, you can see that there is the add-on. So now I'm going to open up a simple blend file. It contains a simple rig with a simple stick guy. Very simple. No constraints, no control bones. And this type of rig is the best way to show off most of the functionality. If you plan on working a lot with motion capture data, I find it's easier to work with a simpler rig because in any case most of your animation is being done by the motion capture, so you don't need the complex rig structure that keyframe animation needs. However, in the later tutorials, I'll show how you can also obviously retarget animations to those types of rigs. So the second step we're going to do is import a motion capture file, BVH format, and this file is from the Carnegie Mellon database, very large motion capture database. I'm sure a lot of you are familiar with it. And if you Google, you can find places where it was converted to BVH format, and that's what we're going to use. So I'm just going to import the file. Takes a second. And we've imported the file, and there it is. It's a simple walk animation from Series 6 of the Carnegie Mellon database. I'm just going to set the scene to 500 frames because that's roughly the length of the animation. So the first issue, as we can see, is that the animation is walking up the z-axis instead of across the y-axis. That happens because different 3D packages use different axis systems. And under the 3 new panels that are added by the add-on, under the Object section of the Properties window, you can see those mocap tools, mocap fixes, and extra mocap tools. So under mocap tools, which is the first kind of stop along our workflow, we're going to just hit Fix BVH Axis Animation Orientation. So now we can see that it's going the right way. The second step is to scale down the performer so we can easily see the 2 rigs next to each other. I'm just going to hide the mesh and select the user skeleton. Now throughout this tutorial and in general throughout the documentation of the user manual and basically everything I've written about this project, we refer to the source animation, that is the motion capture file, as the performer, and the user rig, your rig, as the end user skeleton. So if you come across those terms, that's what you need to know. This is the performer, this is the end user. It says it here and in another couple places. So we're just going to hit auto scale performer, and now it's been scaled down roughly to match the size so we can easily see them on the same screen. Just going to move him a little out of the way as well, and now we can really see. So another good step to do is activate names on both of the rigs. So we can easily go to the next step, which is defining the hierarchy between the 2 armatures. In order to retarget, the system needs to know which bones match up to which bones in each of the hierarchies, because every rig is different. Your rig might be named a certain way. Different motion capture sources name their rigs in a different way. There's no real general guidelines, so you have to do this manually. You can speed up the process slightly by hitting Guess Hierarchy Mapping, and that filled in some of the forms. As you can see, as soon as we selected both of the rigs with the end user rig being active, we have a list of all the bones in the performer wig, all list of all the bones, and now we just have to match up what goes with what in terms of which bones correspond with which bones between the performer and the end user. I'll be explaining what these buttons and these buttons do in a moment. But first let's start to set up the hierarchy. So as we can see here, lower back on this armature kind of goes with torso in this armature. They're both in the same place, so we're just going to go to lower back and find torso. Spine goes with chest. We can also obviously type in, because this is a Flender dialog. Now, another thing this system allows you to do is retarget a number of bones to a single bone in the end user. As you can see here, there's spine 1, neck 1, and head. But in our rig, we only really have head. So what we can do is we can just retarget all these 4 bones, including the head, to our single head bone. And it will kind of blend all the rotations together. To speed up retargeting, what we can do is we can select the head bone, and we can press this button, which is select a bone for faster mapping, and that it automatically fills in. It's often quicker than typing in, although that's an option as well. So the guest mapping kind of helped us along by figuring out the shoulders and the high arm to left arm correspondence. So we just have to wig the low arm. And I'm also going to include the hand. You don't have to retarget every single bone, so I'm just going to leave the left thumb, left finger base, and left hand index bones unmapped. That won't affect the retargeting, as we really don't have fingers here. We don't even have a hand bone. But I like retargeting these 2 bones to the single bone because it tends to look a little better. Defining correspondence is often a process of trial and error, as you'll see in a moment. So now we can just go down the list and continue our work. As you can see, selecting the bones is much quicker. If you use auto guess, you'll want to kind of go over the entire list to make sure it didn't make any mistakes. It's still a bit of an experimental issue because it's a very difficult thing to figure out what goes with what. The best way is to have the artist do it. Alright, so now that the mapping's done, we can hit Save Mapping. And then what that does is it saves the data onto your rig. So if you import another motion capture file, which we'll do in a few minutes, it will save the work you've done with the retargeting, and all you have to hit is load mapping, and it will remember everything. So if you're retargeting a number of animations from the same source, this really speeds things along. Alright, so we have a couple of other options here, such as the name we want to assign to it. I'm just going to leave it as the default 0601. Frame skip. Frame skip is, as you can see, the amount of frames to skip for previewing retargets quickly. So as this is the first try of the retarget, I'm going to set this to 10. Makes it go much quicker. And we'll get to what advanced retarget is in a moment. So I'm just going to exit pose mode and hit retarget. And it did that very, very quickly because it's only doing every 10 frames. So the retarget looks good. This type of error is due to the fact that we're doing every 10 frames. So you don't have to worry about that, those snappings. You can see that they always happen on kind of uneven frames. But what I do want to check is how the formed mesh looks. Now as you can see, due to differences between the rolling of the bones and the source of the animation in your end user rig, which is an issue that's difficult to predict, we can see like this type of twist. But have no fear, we can fix that. We're just going to do undo. I'm going to show the mesh. Just undo the retarget. There we go. Show the mesh. And here we have fixed twist on this bone. So just to show you again what our problems with the twisting was, you can see that the hips are twisted, and the shoulders are twisted. So we're going to undo that. Those hip.r and hip.l were twisted, and the shoulders were twisted. So I'm going to hit retarget again. Alright, the shoulder issue was fixed, but because we fixed the twist on these got out of whack. That happens often. It didn't happen with the shoulders. As I mentioned, this is an issue that's a bit hard to predict. The only real way to do it is trial and error. So I'm going to hit the twist fix on the entire chains, on the left leg and the right leg. Hit retarget, and now that looks right. Again, we're kind of snapping because of the frame skip. So now we're going to hit frame skip 1 and hit retarget. This will take a bit of a while because it's retargeting every single frame. You can see the feedback in the console because Python currently does not have access to the Blender progress bar. Hopefully that will happen soon. But now you can see that the retarget went off really nicely. Continue to the next tutorial and I'll showcase even more of the options. Now I'm picking up where we left off after doing a basic retarget with fixing the twist on the bones. And the first thing I want to showcase is what these buttons do. If you noticed, our previous retarget did not copy the translation. That is, the retarget kind of stood in place. I'll just show you that again quickly with a frame skip of 10. As you can see, he's moving in place, he's not moving forward like the original animation. To have it make forward, you have to mark which bones are feet bones. This is important because when he walks forward, we don't want foot skate. We don't want the foot to skate along the surface. We want the foot to be firmly planted on the ground, the same as it is in the original animation. You can see the right foot does not move while the rig is moving forward. So you can select the feet or the toes. I'm going to go with the toes. Once again, trial and error is your best friend here. I'm going to hit retarget. When you retarget with the feet, it takes a little longer, but now you can see that it went through nicely. Again, a little bit of artifacting just because of the frame skip, but the bones are firmly planted. I'm just going to undo this and do it with a frame skip value of 1 so we really get the full feel of the animation. As I said, you can see the progress in the console window, and if you look at the user manual, I've marked a little snail icon for operations that take a little longer. So if something's taking a while, if it has a snail icon, probably everything's okay, just a bit of a slow animation. So now we can see that the animation is moving forward nicely. Now if you notice, while on the original animation, the root bone, in this case the hips bone, has the location F-curves, the location keyframes, but when we retarget, we move that to an empty that's automatically created called stride bone. This helps in a lot of ways, especially with game engine programming and things like path editing, which we'll see later on. If you don't want to work that way and you don't want to use some of the more advanced tools such as path editing or animation stitching, what you can simply do is copy over the F-curves to your root bone and it will look fine. So continue in the next tutorial and I'll showcase some of the IK options, automatic inverse kinematics, that the retargeting system has to offer. Before we quite get to the IK options, I wanted to show off a little bit about the NLA, how we use the NLA system for our retargeting. As you can see, by looking at the NLA system right now, we have 3 objects here that I've animated. One is our original motion capture. We could even press hide, doesn't matter. We don't need them anymore, we've retargeted. And you have the base action, which contains the raw retargeted animation, basically everything we have here. Auto fixes, which you'll see later, are 4 different types of post-retarget fixes that can be applied to the armature, and they can be baked, and they get baked to this layer. And manual fixtures, which is really useful if the anatomy of the two armatures is not exactly the same and you want to manually fix a bit of the rotations. So we're actually going to do that now. I'm just going to put up the action editor as well so you can see exactly what we're doing. And I'm going to select the armature. Now as you can see, his feet kind of go in a bit. Maybe this was a female animation and this is more of a male. Issues like that. Maybe we want to retarget from something that is a human character to something that's more of a fantasy character, like a goblin with shorter knees, or a child, etc., etc., etc. So what we can simply do is we can go into pose mode and we can go into the manual fixes. So after we've set the rotations where we want, we can hit tab like so on the manual fixes. Hit I, visual rotation. That will add a keyframe to the manual fixes action that is associated with the name of the retarget. Exit tab, and we can see that that fix has been applied throughout the retarget. It kind of perhaps hurt the fidelity of our action, but that's just a great, this is mainly just to showcase a way of kind of fixing issues manually by setting one keyframe that is extrapolated across the entire animation. You can obviously delete those keyframes and go back to the original. Let's try fixing the hips. Maybe that will help us. There, that looks a lot better. He's not so much kind of running into himself, tripping over his legs. And if we look at it from the side, we can see that no foot skate and everything looks great. So that's really a useful tool, often to do it on something like the legs or the hip bones or the shoulder bones. If his arms are too close to his body or too far away from his body, it's a really nice option. I recommend using it if you have any problems after the retarget, something doesn't look right, and you've tried changing the hierarchies and it doesn't really work. Just go in and really you can set a single rotation keyframe, have it look exactly like you want, keyframe it using visual rotation, and it will look great. So in the next tutorial I'll get to that IK tools I mentioned earlier. Post-retarget fixes are very, very similar to Blender constraints in terms of the interface, and also a bit in terms of what they do. You can show or hide it, you can change the type, you can change its name, which is mainly just a feature for you. You can turn off if you want it to be active or not, or you can delete it. So the first thing we want to do is we want to eliminate this amount of foot skate. So we want to freeze the maintain position of frame fix, can also be known as the freeze fix. We want to freeze the toes position in this range of frames. That is from frame around 42 to around let's say 97. So 42.97. Smoothing is how many frames you want to blend in to the new position and blend out. 10 is usually a good default. Sometimes you need less or more. It's a good thing to try, but 10 is usually a good default. And the space you want the fix to be in, we want to use world space for now, because that's how you fix footskate. We want it to maintain its position in the world regardless of how its parents or armatures are moving. So the last thing that we want to do is kind of pick the bone we want to fix, which is toes.r. As you can see, it kind of snapped right there. And now there's absolutely no amount of foot skate. If we recalculate the path, you can see that for this entire length of frames, the tail doesn't move, and then slowly smooths out. So if we kind of zoom out now, we can see that that small amount of footscape has completely vanished. And you can go ahead and do the same for all the animations. So there are other types of fixes. A more general type is the maintain position fix, which just simply allows you to kind of lock a bone's position in space. This is useful. Again, you could use this to eliminate footscape, but the freeze one is easier because it just takes the position of the start frame. But this can be useful, especially because with the different spaces. That is, here it's an object space. You can see that the leg is always keeping its position with the armature. If you have a hand, if you have some type of object, this can be used for a subject carrying a box. Maybe you always want the box to be in front of him, so you want his hands to always be in front of him and not move. Another option that's very useful is the other bone space, which uses the bone to option. So if we go, for example, and we choose toes.l, and this fix takes a while to calculate, you can see that now the two bones kind of stay together the whole time throughout the range of the fix, which is 0 to 100. This can be useful for various reasons. Now it's 5 blender units away. It's useful to sometimes edit the motion capture data in this fashion with a few automatic fixes rather than going in and modifying and manually editing, especially when it comes to the way the armature interacts with the environment. I mentioned carrying a box, etc. Another way the armature can interact with the environment is through the floor, which I'll show you. And we're back. What I want to show you now is another post-retarget fix, which is the stay above fix, or you could think of it as the floor fix. It's similar to the floor constraint in Blender, just a little more clever. And here we have a situation where we want the straight walking animation to traverse a terrain that is a little bumpier than just a straight line, and we get this artifact where his leg goes through the floor. So we're going to fix that by adding a stay above. Now you can notice that I've added IK constraints to both the toes and the foot during the retarget process. For this type of fix, it's useful to have constraints on both. Otherwise, the foot can go through the floor and the toes won't, and vice versa. You kind of have to set fixes on both. So stay above. So we'll define a mesh, which is just plain, and we'll define a range, which is the entire range of the animation, basically. I mean, yeah, pretty much. And we want to define a bone. So let's kind of start with foot.all. So foot.all. Now this this fix takes a bit of a time to calculate because it's it needs to raycast. Now you can see that it made the foot bone go a little higher, but because while the bone might be right on top of the plane, the bone might be right on top of the plane in the correct position, the mesh isn't. And we can just fix that by setting here a small offset. Let it recalculate. Okay, that was a bit too high. This fix is a little slow because we're raycasting within Python for the entire range of the frames. But yep, that's already looking a little better. We can see that there's still a little amount of the mesh traversing the floor, But before we try and fix that by increasing the offset, we can also add the same type of fix to the toes. So toes.all, range of 500, plane. Let's set the same offset. Alright, now it's still going through a bit, so we're increasing the offset slightly. And that's already looking pretty good. You can obviously continue tweaking it. And it also, of course, baked the position of the next foot plan. So by using that, you can ensure that your objects don't go through the floor. The reason why it's called stay above, because at this point it only works in the global z-axis. If there's enough demand, that can be changed if you want characters walking up walls or something like that. But there's another way to edit the way your character walks, and that's through path editing, which I'll be showing in the future. It's part of the extra mocap tools. Hello everybody. Now I'm going to showcase a bit of the extra mocap tools. Following this, we'll be covering advanced retarget, which deals with more complex armatures such as Sintel, which will be the example I'll be using. That's in a few minutes. For now, I just want to showcase your options regarding retargeting multiple animations. So, as I said, we're going to kind of do this walk animation again. No IK, just the foot set, and I'm going to hit retarget. And there's our walk animation. So what I'm going to do now is import another BVH file from the same series, number 5. This is a character dribbling a basketball. Alright, so we've imported it in. Select the end armature, hit load mapping, and there we go. Everything went back up. But just before we retarget, we're going to want to fix and auto scale just because it's a little more convenient. And there you go. You can see that now we can just mark the toe bases again. You can see the action name is now 5 instead of 1, and retarget. Alright, and now we've retargeted a dribbling animation. Now if you want to switch between the retargets, you can just go to this window, and here you have the list of retargeted animations, and you can just switch between them. What this actually does is, if we look a bit at the NLA panel, you can see that the NLA actions are set to 601, and switching it here just switches them to 5. So that's an easy way. Now, another great thing we can do is, of course, stitch the animations. So we'll go to 6 and 1. And stitching the animations means setting them so they blend from one to another. That is, we'll want our character to take a few normal steps and then start dribbling the ball. You can choose the stitch frame, that is the frame where you want the animations to blend. The blend amount, that is the size of this transition. And the second offset is, for the second animation, you often don't want to start it on the first frame. You want to start it kind of somewhere in the middle. You can do this manually by kind of looking and see where the good blend values are and so on. Or you can use guess settings. The last option is stick bone, which is very important because when you're blending animations, obviously some bones are going to have to move a bit unnaturally for the animation to blend well. But the best way to prevent artifacts is to choose a single bone that will maintain its position. For example, if you're in this example, you can choose the foot bone that is being choose a foot bone. Okay, for example, here you can choose a foot bone, and that will provide the best look because there won't be foot skate, which again is kind of the worst artifact there is. So I'll just choose foot.l and hit guess settings. This takes a while. This is one of the slower operations because it kind of has to analyze and compare both animations, which each one is about 400 or 500 frames long. So we'll just wait a moment. Alright, and once it guesses, it prints the guess to the console and sets the things automatically, and we can now just hit stitch and see what it came up with. So if we look, we can see that. Oh, that looks terrible. Let's try to increase the blend amount and try again. I see the hips are doing a full 180 rotation. Oh, interestingly enough, you can simply see that the guess has kind of failed, and it's chosen frames where the feet are actually reversed. That is, if you notice here, foot.r is behind foot.l, and here it switches to be in front of it. So let's set our own stitch frame. By moving to where the second animation, you can look at it by just turning these off, where the second animation has its foot forward. That is, here you can see that toes.l on 136. That's its best foot forward. Turn these back on, stitch animation. Oh, and that's already looking much better. Let's increase the blend amount a bit. Stitch the animations. Oh, that's increased it a bit too much. Stitch animations. Ah, and there we go. It's a pretty good blend. It goes a bit too fast. If we increase the blend amount, that can help. There might also be we're asking it to do a bit much. That is, we're asking it to blend from there to there. So let's kind of maybe lower the offset on this. It's a bit of trial and error. There's not much you can do about it. I'm working on improving the automatic guessing, but it's very complicated. But that lets you kind of fairly quickly stitch two animations together. That's looking pretty good already. See, he blends in from walking to a nice stitch, to a nice dribble. The final extra tool I want to kind of showcase is the follow path tool. So here you can see we have our favorite walking animation again, 500 frames long. And we want this to follow a curve. So we hit curve, add path. There it is. Now let's make the path a little more interesting. Say something like that. Select the path. Select the stride bone empty. Follow path becomes activated. Hit follow path. And there you have it. He's walking along the curve. Now, obviously, as always, foot skate is our biggest enemy. Let me just hide him. So let's see if we have any foot skate. As you can see, we don't, because the tool automatically calculates the correct speed of the curve to fix foot skate. This only works if the curve is roughly the same length, that is, it's the same length of the distance. Excuse me. This only works if the length of the curve is roughly the same as the distance the original armature traveled. That is, if you notice, if I make the curve longer, we're going to get noticeable foot skate here because he has to just travel too much and he doesn't know how to handle it. So as long as you use the same amount of curves, that works pretty well. Another thing you can do is convert your animation to a cyclic animation, set extrapolation to cyclic, and then the animation will just cycle through and you can make your steps, your pass as long as you want. Path editing is another great way if you have to have your character traverse other complicated terrain. Just draw a curve or project the curve onto the floor and have him follow that, and that'll work pretty well. A couple of other kind of finishing touches I want to show before moving on to advanced retargeting is what to do when you're kind of finished. Well, obviously you can keep working in the with the 3 NLA tracks and keep it like that. I'm sure some artists will not want to do that for various reasons. So it's actually very simple what you can do. Just select them all. Open up the bake action operator. Set your frames. I'm going to clear only selected. Whoops. Pose an object. And this takes a moment. And it'll bake everything we've done, whether it's auto fixes that have been baked in the NLA track, manual fixes that we added in later, whatever it is, everything has now gotten moved to just an action called action. And there you have it. Now another very useful thing you can do is, so now that we've baked the entire retarget to a single action, we can just go into the back to the properties menu and hit samples to Beziers. And this is quite a lengthy process because it mathematically is pretty complex, but this will process the curves, the F curves for the entire animation, and simplify the curves. That is, instead of having a sample on each frame, it will convert it into Beziers that appear every 5 frames, every 10 frames. It automatically figures out what the best configuration is to minimize the difference between the heavily sampled data and the Bezier curves. And also it places keyframes on the same frame for every bone. That is, the rotation in the X, Y, and Z axis of a single bone will have the same keyframe. That is, on the same frame, their values will be keyframed. So this process takes a while, usually around 2 minutes for an animation like this, containing about 20 bones over 500 frames, again, you can see the progress and output in the console window. So we're just going to wait until this process ends. And now we can see the process finished, and instead of keyframes on every frame, it's kind of been modified to be more efficient, and you can see that without losing much of the animation fidelity. Oh, that was a bad keyframe, you can just delete it. We have a baked motion capture retargeted to our own armature. And if we just enter the graph editor, hit home, undo that, you can see nice Bezier curves instead of samples on every frame. I just want to mention, I didn't develop this, but there's also a second tool for performing this operation. It's quicker, but its performance is not as good in terms of specifically for motion capture, and also it doesn't set the keyframes on every frame correctly. But under Add Curve, you can see there's the Simplify curves written by Test Screenings, and you can hit Simplify F curves. Convert Samples is my tool, Simplify F curves is his. Here you can increase the error you want. I use the default error value, and that also allows you to simplify the errors, but as you can see, it can often create artifacts, especially if you're using quaternion rotation and not Euler translation on your bones. Alright, so the next step will be advanced retargeting.